Recording in progress.
Okay, so any questions on any of these problems at all, like rewriting from log from exponential form, exponential log form, evaluating logs, calculator ranking these, solving equations, graphing? No, it's all should be review. I know Algebra 2 Trigonals is a very thorough log review, or the very thorough log lesson or topic or unit, whatever. So you guys are cool? All right. Okay. Then let's just move on. All right, let's move on to the properties of logs. Actually, I like this a lot because this kind of expands what we can do with logs. No pun intended. You guys don't get that? Because we increase expand logs, especially if we expand our knowledge. All right. Stop. Okay. Ah. All right. And that was unintentional. I didn't mean. That's just pretty organic there. All right. And product rule. Here we go. I'll stick with education. That's my bag. All right. No career in comedy. So yeah, my handwriting sucks here, but yeah, we're just expanding. So we're just if you have a product, you write it as a sum of two logs, right? If you have a quotient, you write as a difference of two logs, and always maintain the same base. Now, I do want to show you some challenge problems because we have a test on this next week, and I am going to challenge you a little bit, and I want to expose you some challenge problems. So I'm going to do that later today, so you guys can see what I'm thinking in terms of how I'm going to push you guys a little harder at this stuff. Because I know you guys seen this before, so I could like say, oh yeah, here's a log, just do this, no problem. But I want to make you guys think a little harder. But at the very least, we need to know the foundations, right? So this is part of the foundations. That makes sense. You guys remember all this stuff? And I could go through the derivations. Actually, I kind of forget how derivations look, but these are very closely tied to rules of exponents, right? Like for example, if you have like x to the m times x to the n, what would that be? And it's quite analogous to the product rule, right? If you're multiplying two powers of the same base, you would add the exponents. It's pretty similar. I think there's some sort of nifty derivation you do with this to make that make sense, but I just can't remember how that looks, so we don't need to do it. I think you guys get the point of how the properties work. Or for example, if I have this here, how do I combine those two exponents? You subtract, which is very similar to the quotient rule, right? Very, very similar. Or if you have this here, how do you combine those two exponents? You multiply, which is kind of similar. I don't know if that makes sense, but but they're all closely tied together. Now, if you have natural log, guess what? Do the same thing. Who cares? As long as the bases are the same, you can do this. So that's what just has to matter. That's what matters. The bases have to be the same. And the base is that's a typo, should say base B, not A. You got that. Okay, so let's do this in practice. So if we expand this, what happens here? Good? Yeah? Pretty simple. Okay, cool. How about Ken, do you need notes or? Oh, I'm sorry, yeah. I just thought you had notes out. Take care. Oh, excuse me, sorry. Kind of front of you. All right.
It's at 9 a.m.
What's the water about?
Okay, guys. Well, I know that what you guys will do that, so don't worry about it. But hope I get some for 9 o'clock. So you guys, yeah, I should. Yeah. Do you guys see what I just did here for this one? Yeah, well, I'm not done yet. What's log base 3 of 1? 0, and they have -2 log base 3 of x. So actually, I can get rid of that 0 because it's kind of redundant. And yeah. So sometimes we do want to evaluate along the way, if we can, when you're doing the expansion. But what I really care more about is condensing. Condensing is actually more crucial because when we solve log equations, or even in calculus, when you have a bunch of log expressions and you have to apply some calculus principles, you need to simplify it first. And the condensing allows us to do that. The condensing is actually more crucial than expanding. But expanding is just good just so you know the properties, so you understand how they work. But now we're going the other direction. Base 3, 1 is 0. So 1 away. Oh, there's more. Okay. Why don't you guys try these next 4? All 3 is the screen. And we'll check in about like 2 minutes. I don't think it should take too long.
So anything like log of 1 there?
Correct. That's correct. Oh, sorry. Hold on. Let me undo. Shoot. Hold on. No, I got you. I got you. Hold on. There you go. I'll freeze that. There we go. I'll work on B through F, and you guys do the same.
You want us like converting it from log into like actual numbers?
Sorry, repeat that again.
Like-
Yes, if you can. Yes, if you can. If you can about excuse me, if you can evaluate, yes, I prefer you do that. No, it should be good numbers. Oh, log 2. No, oh yeah, log 2, log 8. No, don't worry about that. Any you can do in a calc mentally. Log 1000 you can. Yeah. Okay. Yeah, exactly. So hopefully you guys got those for B, C, E, F. So yeah, log 8, log X, log 4, log Y. Remember the 4 only goes to the Y, not the 8 and X. Here, 4 only goes to the X, not the 1000. So make sure you're mindful about that. Here the root is 1/2, so you have to convert to a fraction exponent. Yeah.
So could you do 1/2 natural log x squared plus 1/2 natural log 5?
No, because these are not being multiplied.
Oh, yeah.
Well, I'm glad you brought that up. Okay. Please don't do this, guys.
Or you can do it multiplied then,
How?
like 1/2 natural log x squared.
Nope. Nope. Because here's what you're doing. You're trying to break this apart like that, I think. So you're trying to do? Yeah, you could do that if there's a times a plus in the middle there. Then we could do that.
Yeah.
Yeah, if I had log 5x, natural log 5x squared, 100% you could do that. But we don't. So don't mix up the properties, very important. Maybe I should do the derivation then so you guys see why. But that's okay, just don't mix them up. Yeah, so because kind of like, for example, going back to exponents, right? Like if I have x to the m, like for example, if I have this here, right? Is there any shortcut for that? No, just it is what it is. Like if I have x, like if I have x squared plus x, so x cubed plus x squared, guess what? It's x cubed plus x squared. I can't do anything about that. But if I have this, can I do something about this? Sure. X to the 5th. It's the same thing. We don't want to mix it up. I think we see this very easily because we know when we're multiplying a bunch of numbers. Like you have like 2 cubed and 2 squared. Sure, it's 2 to the 5th. You multiply 2 5 times. So here if you have 2 cubed plus 2 squared, sort of order of operations, we don't do that, right? So think of PEMDAS as well. Logs are actually the same hierarchy as exponents in the order of operations. Treat it the same way. Right? That's what you want to do. All right, now I think we have condensing. Yes, awesome. This is what I care more about. Actually, looks like we are going to do the proof. Okay. See if I remember how the proof works. Okay. Here we go. Use the 3 main property logs to condense each log expression. Okay. So that should be pretty simple, right? Not that hard. What about for B? Perfect. Good. How about for C? Yeah, or you could write like this. I don't really care Whether you lose a fraction, exponent, or radical, doesn't matter to me. Okay, now we have to start being careful of the other ones. That's a common log. Cool. Here, ooh, it's a fun one. What should go up top? What should go bottom?
Natural log.
What's up top?
Oh, sorry.
X fifth. Oh, right. Yes, yes, I did see that. You're seeing ahead of me. Good. And what's the goes on the bottom? Yeah. Actually, let me do this first, just so I don't confuse people. And then we can simplify after that, which is x cubed or y squared. Good. Okay. Yeah, because what's happening is that you have a negative in front of two logs, so it puts both of them on the bottom. Okay. And then for f, and so I kind of condense. Hmm? Wait, say again?
Like, is there a way to put that y squared in the denominator below x squared, so it's like another one?
No, well,
It would end up being the top, and I'm just wondering.
actually, okay, I know what you're saying. So true, if you combine these two, you have x5 over x squared. And then you're dividing this by y squared. I think that's what you're saying, right? Okay, but that y squared is like y squared over 1. So you have a complex fraction. When you flip the bottom fraction, the y squared over 1, it becomes 1 over y squared, which still gets you the same thing. Yeah, you could. But yeah, and actually, you should be able to see that. It's good to see that, truly. But I think kind of the shortcut's like, hey, we got two negatives. Let's put both on the bottom. But yes, that is true. If you go from left to right, actually, that's how I probably should have approached it. But yes, you can. Now, for here, notice the 3 rolls back and the 2 rolls back. So you should get natural log of x12, y3 plus natural log of y squared z10. And then combine that even more, which should be what? x12, y5, z10. Is that right? Yeah, okay. All right. So that should be pretty straightforward. Again, we're going through this pretty quickly. In terms of the proof, let's see if I can remember how this proof works. What does b to the x equal here? Okay. What does b to the y equal here? So if I multiply r times s, wouldn't it be b to the x times b to the y? You guys would agree with that? And then kind of combine that even more?
Yeah.
As what? Well, b to the x plus y. Right, okay. So then, oh, okay, I see how this proof works. Oh, this is really nice. Okay. So far, we're cool with this, right? This all makes sense, right? Okay, cool. Right. Oh, this is very nifty. Okay, so then now you guys have no reason to mess this up because I've shown you the proof. Well, I'm about to show it to you. So if you rewrite it into log form, wouldn't it look like this? You'd agree with that, right? So to go from the second step to the third step, if I rewrite this as a log equation, what's my base of this power? B, so it becomes the base of log. What's my exponent of x plus y? What's the whole point of logs? To isolate what? The exponents, so the exponents go to the other side. And then the output now becomes the input, as it should be. Remember, inverses, exponential and log function inverses. And then lastly, what did x equal in the first place? That, right? What did y equal in the first place? That. So you can now replace x and y with what they were originally. And voila, there is your product property. See, I didn't remember this off the top of my head, so I'm glad I had the guiding guiding steps here. I'm not gonna ask you to do this on a test, don't worry. But but that's why it works. Now don't mess it up. And you can do something very similar for quotient property and power property, but we won't do that in the interest of time. But that's why it works. Hopefully that's kind of a nifty little proof. Okay, change the base formula. Do you guys know about that? you could rewrite any log as a ratio of 2 logs. And you change the base to like maybe a common log or a natural log. So this could work, for example, or this could work. This is how I used to do logs before all the fancy calculators came out. So like, for example, if I had a old scientific calculator, like a Casio, like scientific calculator like 30 plus years ago, if you come at your parents, if they have any old calculators, maybe you might be able to find in the garage or basement or whatever. Hold on, Ollie. But if you have like log base 2/8, you could punch in your calculator, right? But back in the day, if I had to evaluate that, I mean, I know the answer is 3. Back in the day, if I had like one of those old school calculators, they didn't have a subscript feature. I actually only had a com log or natural log button to press. That's how I had to do it. I actually had to type in log 8 over log 2. Or the natural log over natural log 2, you can do that as well. If you so desire, you could actually do any base you want. Like if I wanted to, I mean, this is really weird. I don't know, I'm still in a Squid Game mode, but I could I could do this. I am, you can tell. And White Lotus too. That's another show. Yeah, okay. But like I can pick a random number. I randomly made it up, but anyway. But you can do that. It doesn't matter, right? As long as these are the same. As long as those are the same, right? Doesn't matter. If you call your question, yes.
So then is log base b of x log x minus log b?
No, it's not because you're mixing up the properties again.
It's division.
It's division inside the log. No, this is what you're doing.
So if log
Yeah,
x
guys,
minus log b.
yeah, please don't do that, guys. So
Okay.
it's log of b over x will be log b. Yeah, please don't do that.
Okay.
Yeah, it's not subtraction. Maybe we should do that proof. So that's okay. All right. And so why does this work? Because if you think about it, x equals b to the y. And I know you guys like to take log of both sides to solve these equations, which is totally cool. So if you do base a, for example, log base a of x equals log base a of b to the y power, what happens to the y? It multiplies, right? So log base a x equals y times log base a b. And so what does y equal? Log base a x over log base a b. So essentially what I've done is I've taken this log expression, came with a new base a, log base a of this, and log base a of that letter d will equal the same thing. So if I have like log, just one more example before we go on the next page. If I have like, I don't know, log base of 1.2 of 8.6, I can write like this. What base am I using here? I know my handwriting sucks. Yeah, it's the same thing. I can punch this in a calculator. I'll do some weird number. I can put these into my calculator. I'll still get the same exact weird number.
So you use any base.
Any base, but make sure they're the same. Yeah, make sure they're the same. Very important. Yes, doesn't matter. So I think sometimes we're going to have to use these rules in calculus, like when you're doing some more advanced calculus stuff. Not this year, we won't do it. Again, we are going to do calculus when we come back from ski week. But yeah, you know, just things like that. Just know those properties because you have to tap into them. So like over here, about the following, use the change of base formula, use either base 10 or e, round to 3 decimal places. So let's see here. Let's do common log. I trust you guys can punch this in the calculator just fine, so I'm not worried about that. So I'll just kind of do the answers quickly so we can keep moving. Be very careful. Make sure you close the parentheses in the calculator because then it'll just like the calculator does this. We hit log. So you put 19. What if I did that? Or sorry. and didn't close my parentheses. What do you think it's doing?
It's gonna do this log 5 and then divide by that and then do log of that expression. You really need to make sure you close the parentheses.
Be very careful when you punch in the calculator that you close the parentheses. That should be 1.83. No, 1.82 next. We gotta do 3 decimal places. Excuse me, 259 divided by log 12. That's 2.236. Log 29 divided by log 0.2. Ooh, negative. Negative 2.092. That's 2.236 for the middle one. And the two common mistakes, which Clay and Ollie shared with us, don't do this. Don't do that, right? And another one, I think you said this, right, Clay? There are more. I think these are the two common ones. That's not true. Or some people might do log x times log y equals that. Some people might do that also. Just be careful. Don't mix things up. Yeah, I'll put some more up here, like, log. That's not true, right? So anyway, we're only thinking one more here. That's not a thing either. So yeah, just make sure we keep all the properties straight. Okay. Good. All right, let's keep moving. Once you guys try these true and false problems, ooh, this is good. This is really good. Try true and false problems. Then we'll move on to the last page and we'll be done. So just want to take up a couple minutes here. And I'm actually putting corrections, just so you guys can see the corrections. Yeah, I think. How many trues you guys get? Good, I agree. Here we go. Yeah, for the bottom left,
That's gonna be 2 log base 5x. And if you have 2 of the same expression, then you're adding each one individually, right? So it should be like that amount of time usually. Obviously that's x log x minus log 4. That one, there's nothing special about this view, but this you can combine log natural only 2x, right? Multiply. Here, you break apart as a sum, right? Log base 7 plus log base 2x. Can't do that.
and change basis happen in the lower right corner. The other ones are using either power property or quotient property or product property. So
Products right here. In the second row to the left. Right next to it on second row to the right, and quotient right below that. Third row to the right is power property.
okay. Okay, cool. All right. Let's do a little more. Then we're done. Composition. So when you plug one function to another, that's what composition means, right? Not that hard. So G4 means I gotta do 2 raised to the log base 2 of 4, right? Because I have to do log base 2 of 4 first and then throw it into the 2 to the x equation. What does that wind up becoming? 4, yeah, exactly. What if I do the other way around? I do log base 2 of 2 to the second power. There comes 2. So f and g are inverses of each other if and only if f of g of x equals g of f of x, which equals x. Always going to equal the input. So what this means is that if I do f of g of x, b log base b of x, that's just basically just going to be, well, I don't know why there's 2 spaces here. Hold on, I'm a little confused. That's just x. I don't know why there's a second space there. I'm a little confused. Or here, that's log base b of b to the x. That's just going to equal x. Just so you know. Oh, I think I know what they want us to do. Yeah, hold on. Let me just undo really fast. I think I skipped a step. I think they want us to show this. F of log base b of x, which is, of course, b log base b of x, which of course is x. And
They
here,
want you-
right.
Starting with log base b of b to the x, you can just make it like x times log b of b.
Actually, you could do that for that one. Sure. You could. Yeah. Yeah, because that is like saying x times log base b of b, which is x times 1, which of course is x. Sure. Yeah. You can think like that too. Okay, we're okay with that. So we just found 2 important properties. Can I move? Yep, okay. 2 important properties is log base b of b to the x equals x, and b of log base b to the x is also x. So that's easy. 4, 3x, and 2x. That's all. Pretty simple. Some students will do this. They'll like, don't do that. It's kind of bad form. They'll drive your calculus teacher nuts, whoever teaches you guys calculus next year. Yeah, don't do that. Because that's not really what's happening. You're not doing division or multiplication. It's just an undoing, right? You're plugging an inverse into itself. They just undo each other. So it just becomes the input that you see. One last thing. Trying to think. If I go to my Algebra 2 trig honors folder from a long time ago, when I taught this. You can see how long I taught this. Well, 2016. I first started teaching this in 2011, I think. No, 2009, actually. Yeah. Yeah, some of you guys were like just like babies then. I'll try to find a good problem here. Hold on, I had an extra credit one. Maybe here. Shoot, I don't see it. Darn it, I really wanted to find this problem. It's driving me nuts. Well, let me just show one of these. Like something like this here.
This kind of crazy a little bit. So yeah, 2 to 2x minus 3 times 2 to the x equals 4. What you can do is replace 2 to the x with a different letter, any letter you want. I call it a. So that becomes 3a. Oh, this becomes then. You have 2 to 2x. How would I write 2 to the x in terms of a? 2 to the 2x.
2 to the x to the 2.
Okay, good. That's a good start. You would agree with that, right, guys? If I deconstruct that power, and that's just a. But what's 2 to the x? What am I letting equal 2 to the x? Okay, so wouldn't that be a squared? And what is this one I'm solving now? Quadratic equation. What does a equal? And guess what? 2 to the x equals 4. What does x equal? That's the answer. Can 2 to the x equal -1? No. So that's extraneous. You don't worry about it. So things like that, I want to kind of expose you guys to. So I think that would be good. Gosh, there's another one that I'm really trying to find. It has like 2 logs on each side, but they have different bases and how to solve that. And I can't find it for the life of me, but I'll find it some for tomorrow. So I'm done. You guys can work on homework, or if you want to do the protest, you're more than welcome to do that. So, all right. Or you can stay here.